Okay, so we just worked on scientific notation, and now the topic today is prefixes, and it's very similar to scientific notation. It's basically a shorthand method of communicating very large or small numbers. Okay, so it's very similar to scientific notation, except for we use prefix. So we use a prefix letter, and what we do is we attach it to the unit. And that, by attaching it to the unit, it communicates how large or small the measurement is. So just a note, if you can't do scientific notation, you won't be able to work with prefixes because they go hand in hand in understanding the size of the measurement. Okay, so here's a set of 20 prefixes and 20 powers that relate to those prefixes. Some of them you'll be very familiar with. For example, if you look at kilo, kilo can be represented with can represent a power of 10 to the 3. For example, centa represents 1/100th, which is 10 to the negative 2. Milla represents 1,000th, which is 10 to the negative 3. So those are the really common ones. Some other ones you might be familiar with would be gigabytes, okay, so 10 to the 9. In science we use micro, nano, and pico quite a bit. And you know, some of the other ones are kind of rare to see, but they do come up occasionally. So what we're going to do is we're going to look at how we actually use these. So let's take a look at some examples. So we're going to start off by converting numbers that are in scientific notation, or it could be scientific notation or standard notation, depending on which you're starting with. So from standard notation, you would want to write the number in scientific notation. Then we take the power, x to whatever, or times 10 to the whichever exponent it is, and we'll replace that with the correct prefix. Okay, so let's start with this example here. So 8 times 10 to the 3. Now if we want to write that with prefix notation, what we're going to do is we're going to take this and we're going to replace it with the letter that goes with it. So we go back and we look for 10 to the 3 times 10 to the 3, and the letter that will replace it is kilo, K, and that's it. So we have 8 kilometers. Okay. Here's another one. We have it in scientific notation already, so we don't have to do too much. We just look for the exponent, or look for the power, 10 to the negative 9. That's going to be nano. So we put in, use an N for that. Oops, wrong way. So it's going to be 5 NS, so nanoseconds. So let's say you're reading a physics or chemistry textbook and you come across this 5 nanoseconds. You know, if you don't understand what prefix is, you wouldn't know what the value that number has. So it is important to understand this. Just a communication tool. Oh, so now we have 10 to the 6. We go across and we're looking for 10 to the 6. We've got mega, capital M. So that's 2 megamoles. All right. Now let's look at some examples where we have standard notation. So for this, we need to do the first step. So we have to get to scientific notation first before we can do the work we did over here. So this is going to be 4 times 10 to the 3 meters, and we already found 10 to the 3. We look across, that's kilo. Okay, so that's 4 kilometers. All right, now here we have we've moved the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 3 times 10 to the negative 9 seconds. We already did this one. 10 to the negative 9 is nanoseconds, so 3 nanoseconds. Okay, so if you don't have scientific notation, you need to figure that out first. So here we have 4.7 times 10 to the 4. We need to move over 4 spots there. Moles. Now a little problem is going to come up here with the 4 times 10 to the 4. So if we look for it, I'm just going to erase this mess here. If we look for it, 10 to the 4 fits in between these two, so mega and kilo. So we want to decide, what do we actually want to write it in? Do we want to write it in mega or kilo? What is it? Moles? Mega or kilo moles? For example, maybe your textbook says provide the answer in megamoles, and then you'd want to go to 10 to the 6. Or maybe it says provide the answer in kilomoles, and you go to 10 to the 3. So let's put our answer in kilomoles, and so let's see how that's going to work out. I'm just going to make a little space here. So if we have 4.7 times 10 to the 4, I'm going to zoom in on that. Let's say we want to go to times 10 to the 3. Okay, and that'll allow us to write it in kilomoles. That's what we want in the end. There should be no space in here. Oops. All right, so now we think, okay, we've made an adjustment here. We've gone down 1 power. So essentially what we've done here is we've divided by 10 to the 1. So what we have to do here is times by 10 to keep it balanced. If we divide by 10 over on this side, we need to times this by 10 to balance it out. So we have 47 times 10 to the 3, so we have 47 kilomoles. Okay, so that's one way to write it. Now, let's say we instead want to go to megamoles. We're starting with this. Okay, so that's going to be, we want to go times 10 to the 6 moles for megamoles, and that allows us to put the m there. Now, let's say, let's take a look at this and see what we did here. What did we do to go from here to here? We times by 10 squared. Okay, we multiply by 10 to go from 10 to the 4 to 10 to the 5 to 10 to the 6. So we times, essentially, what we did, we times by 100. That's what this is. So if we times this by 100, we have to divide this by 100, or 10 squared. And so we move the decimal 2 places to the left, and we get 0.047. So it's going to be 0.047 megamoles. Okay, and that's how you can get this value converted to one of the prefixes, and maybe you choose the one you like, or maybe you're told to provide your answer in a specific form, and then you would do that. So that's a little more complicated, but it's all about kind of balancing it out and making those adjustments. Alright, so now we're going from prefix to standard. So this is, we just do the exact opposite steps. So here we have 2.5, and what we're going to do is we're going to replace this times 10 to the, and we figure out what power is it going to be. Giga, look for the G, and replace it, we go the other way. So 10 to the 9. So 10 to the 9 bytes. Okay, now we need to write it in standard form. We're trying to write the standard value. So 10 to the 9, we're going to have 2, 5, and then 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so and there's our answer. We want to write our units too. Okay, here we have 7.5 times 7.5 nanoseconds. So 7.5 times 10 to the, again we've used that one already a few times, -9. Put our unit. So that's going to be 8 zeros, 0.1, 2, 3, 4, 5, 6, 7, 8 zeros. My first digit, so it's 9, and then just finish off with the remaining numbers, so just a 5. Okay, so that's what 7.5 nanoseconds, that's the value of it. Couple more here. Let's say we have 7.6 times 10 to the, let's replace that. Let's look for it. Micro, 10 to the -6. -6 meters, micrometers. So we're going to have 5 zeros, and then 7 is the 6th move. So 1, 2, 3, 4, 5, and then 6, and then just put that last value in there. Okay, 18 millimeters. So 18 millimeters, we have 18 times 10 to the, you might know this already, but millimeter, we've got 10 to the -3. Okay, meters. So now we're going to move it 3 times to the left, so 0.018. Right, if you started here, you go 1, 2, 3. Right, you can still do these if you need to, these moves, decimal moves, but once you get the hang of it, you don't really need to do it as much anymore. Okay, so 18 millimeters is 0.018 meters, and you can see that this is actually another way to do unit conversions. When you're working with length units or time units, metric unit conversions can be done with prefixes, and understanding the relationship between any two prefixes. Okay, let's say we're working with 18 megamoles, so it's 18 times 10 to the, alright, you might have remembered this one, but it's M is 10 to the 6, so 10 to the 6 moles. Okay, so we're going to take, there's a decimal here. This isn't actually in scientific notation, but we have the power we need. So just like this is not in scientific notation, but we can find the power from the right, we can find that power from the prefix. So we do the same thing. We move it 10 times 10 to the 6. That's 6 times to the right. So it's going to be 18 and then 6 zeros. Right, so that means that we've moved it. It was here, and we've moved it 6 to the right. Oh, don't forget our units. Okay, so there is some work. There's a few examples on going from standard to prefix, prefix to standard, and there's a little bit of work here. You're just filling in the chart, getting familiar with some of the prefixes. So, you know, given the scientific, the power, give the prefix and the symbol, and then this sheet you're just applying that work, the examples that we were going through. Okay, talk to you later.